Hi, hello. My name is Kenny Cather. I have a question for you. Who doesn't love music? Me? I love funk music. I can go online right now and find any record, no matter how obscure. It's pretty cool. I'm sure you have stuff you like to find online too. Well, you're not alone. About 40% of the world's population uses the internet. Right now, laws are being written and technology is being designed that could forever change how we use the internet. These changes are coming up against a very hot-button issue called net neutrality. But what is net neutrality? How does it work? And why is it important? I hate to be cliche, but I have to be honest. Like anyone else would do, I went online to read some articles to prepare for this talk. And, well, I have a degree in electrical engineering and a background how computer networks function, and even I couldn't make it through some of those articles. They're just so boring. Put me to sleep. So don't worry, it's not just you. Even engineers are bored to death by some of the stuff out there. So my parents asked me, actually, what is net neutrality? Why is it important? And they asked me to tell it to them not using technical terms. So I came up with a silly analogy that they were able to share with their colleagues and friends, lawyers, salespeople, accountants, engineers, all kinds of people. And it demystified net neutrality for them. So I thought, so a lot of people are very confused about what net neutrality is and why it's important. I bring my analogy to TED to give this talk. Net neutrality is an umbrella term for several different ideas. The first idea is outside the scope of this talk. It's the idea that everyone in the world has equal access to the internet. Now obviously that's a big problem, kind of like world peace, so we're not going to go there yet. Another idea that's inside the scope of this talk is the open internet. What is that? What does that mean? Also the idea all data is treated equally. Once again, what is that? How does that work? Now, some reasonable people have some very reasonable fears. Some people are afraid carriers will create fast lanes and charge more to anyone who wants their data delivered faster. Others are afraid the government will regulate the internet under a century-old telephone law. Trying to understand all these pieces and ideas and the technology itself can be challenging, which is why my analogy uses two of the internet's favorite things, pizza and kittens. Now, I'll be speaking in terms of layers because that's the word engineers have agreed upon to talk about the internet technology. Our first layer is all the bits and bytes that make up whatever you download online. Internet traffic is made up of little things called packets. All the packets that make up whatever you're downloading are delivered one by one. So let's go to our analogy. Let's think of a movie or a song as a pizza, because a pizza is a whole thing delivered to you. If we deliver it like a packet, we'd be delivering each slice individually by kittens in tiny, super fast cars. The pizza would then be assembled into a whole at your door, the same way an email is assembled in your inbox or a web page is assembled in your browser. Ever watch Netflix and watch some of the great shows like Daredevil? Love it. House of Cards, Unbreakable Kimmy Schmidt. Funny, funny, funny show. Anyway, so we're sitting down, we're watching Netflix, we're watching Kimmy Schmidt, Unbreakable, and it starts buffering. Why is that? Why is it buffering? That's because every kitten has not yet delivered their individual slice. The next layer, the transport layer. This is the infrastructure owned by the carriers. So our routers, our servers, our cables, our wiring, all that fun stuff to just dig in there and play with. That's analogous to roads our kittens would drive on to bring your pizza to you. So our kittens are speeding around in tiny, super fast cars, But how do they know where to go? They deliver it to your address. So the same way every home has a unique address, every computer online has a unique address called an IP address. The last layer is how you use the internet. You use the internet through applications, like web pages or email programs. That's why we call it the application layer. Now, if you think about it, you can surf the web through any browser you want. So Firefox, Chrome, Safari, Internet Explorer. It doesn't really matter. You're getting the same web page. That's because of an interesting idea with the layers. Well, every layer depends on the other layer in the sense you can't have a pizza without first ordering the pizza and having it delivered to you. The technology in each layer is independent of the technology at every other layer. So when you use your web, you can use any browser you want. It's all going to work the same. Or if we change out a router, it shouldn't affect how your internet's working. It might be a bit faster, but it's the same experience. This is like when you order your pizza. All you as a user want to do is call up, place your order, wait 30 minutes or less, open the door, and pay for it. You don't really care which person puts a pizza in the oven, which oven they use, or what car they use to bring it to you. So now that we know how the internet works, let's dig into net neutrality. Let's look at the open internet. People are still trying to define what exactly the open internet means. But basically, right now it means you have access to any legal website whenever, wherever, and however you want it. So what about legally gray websites? Like somewhere where you might, I don't know, Army mateys, shivery timbers, we pirating some movies and music, you scallywags. Or what about websites that come in conflict with the government's laws? Should we have access to these websites? That's something currently being debated in the net neutrality debate. That hasn't been agreed upon yet, but it could affect all of us. Now, if we're going to stop access to these websites, how do we do that? Think of our kittens again. We would not give our kittens the address. If they don't know the address of these questionable websites, they can't get there. And if they can't get there, they can't bring you your pizza. Another way is something called deep packet inspection. This is like setting up checkpoints on the roads, where we're going to stop each kitten, open up their packet of pizza, and look at the topping and decide what to do. So let's say anchovy pizza is pirated information, and we want to stop pirated information. We tell the anchovy pizza kittens, you cannot drive on our roads. Stay home. Don't even bother coming on these roads. Now, this deep packet inspection is also where the idea of fast lanes comes from. A carrier could decide, okay, pepperoni pizza, you want to go faster? Pay up. And you can go faster. Another fear people have is the carrier might say, pepperoni pizza, you want to go faster? Pay up, and we'll make everybody else go slower. Now, part of the problem, obviously here we're not treating data equally, which is one of the ideas under net neutrality. Part of the problem we have, though, is we already don't treat data equally. We already use deep packet inspection and packet prioritization to increase the speed of the internet. Also, remember, you can't eat your pizza until you have the whole thing. So what if one of our kittens gets lost? You're not eating your pizza until they all show up. We can put out a call for replacement slice of pizza, have that delivered as fast as possible, while we go look for a little lost kitten who's cold and lonely and hungry for milk. He's like, meow, meow, I want to go home, meow. Don't worry, no kittens left behind. We'll find him. But in the meantime, a replacement slice is coming out to you. Like I said, we already break the idea of all data treated equally. So part of the net neutrality debate is trying to figure out when to treat data equally and when not to treat data equally. So we're left with a bit of a problem. The current regulation of net neutrality. The FCC has decided to reclassify the internet from information to technology under the Communications Act of 1934. So they're effectively using a 1930s traffic law for today's larger cars, SUVs, and semis. That's a bit of a problem. Our tiny kitten delivery drivers are sharing the roads with huge semis, with large amounts of information, things like movies, healthcare records, enterprise-related data. Our kittens are fighting bumper-to-bumper traffic. We're always in need of figuring out how to make the internet work faster and better. But we're badly in need of laws that will let us do that while still having an eye towards net neutrality. A lot of reasonable people are afraid of a lot of reasonable things. Me personally, I'm afraid of how my kittens will survive a zombie apocalypse. I mean, they're kittens, and zombies are these big scary things. And you have zombie meat. If they eat them with zombie meat, they may become zombies. They gotta somehow find a way to close themselves in while still eating food. How would they do it? I worry about this. Which fear is more rational? I don't know. All I know is the internet loves kittens.